connected ductus XY as shown in figure 1. First one, draw below the relevant part of the circuit to show as to how the resistance R and R0 appear across the points X and Y using circuit symbols. Right. We know voltmeter is connected. Voltmeters are connected parallel to the circuit. No, right? That is a point here. Voltmeters are connected parallel to the circuit. Right? Voltmeters are connected parallel to the circuit. Right? Voltmeters are connected in parallel combination. No? Voltmeters are connected parallel to the circuit. Parallel combination. Right? Now between X and Y, this given R is already here. Right? And voltmeter is connected parallelly. When voltmeter is connected parallelly, we have an internal resistance for the voltmeter, right? That is given as R naught, right? The internal resistance of the voltmeter is R naught. Then that R naught will be connected parallelly. That R naught will be connected parallelly because we are connecting a voltmeter parallelly between X and Y to measure X and Y. Then R naught is connected parallelly with this. Right? Draw below the relevant part of the circuit to show how the resistance R and R naught appears. Right? Then no need to draw the voltmeter, only the resistors, R and R naught. Right? Next, write down an expression for the equivalent resistance RXY across X and Y in terms of R naught and R. Right? Now that is very straightforward because R and R naught are in a parallel combination. Right? R and R naught are in a parallel combination. Since they are in a parallel combination, you can simplify that resistance as two parallel resistors. Then 1 over Rxy equals 1 over Rxy equals 1 over R naught plus 1 over R. Simplify this. Right? Then 1 over Rxy equals, common denominator is R naught R and this is R naught plus R. We need Rxy. Then Rxy equals R naught R over R plus R naught. Right? R naught R over R plus R naught. Next. D. The voltmeter now appears to have been connected across RXY. Appears to have been connected between RXY. Under this situation, will the reading of voltmeter be equal to the value indicated by an ideal voltmeter? Ideal voltmeter connected across RXY. Yes or no? Justify your answer. Right. Now first you have to know what an ideal voltmeter is. Right? If an voltmeter is ideal, this is the explanation part. Listen. Right? Not the answer, this is the explanation. Right? If an ideal voltmeter, in an ideal voltmeter, resistance is infinity. In an ideal voltmeter, resistance is infinity. When resistance is infinity, no current flows through the voltmeter. No current flows through the voltmeter. Because we know, if a current flows through voltmeter, then it absorbs some voltage and it is going to do some error, right? Have some error when measuring a reading, when taking a reading, right? So that's the exact reason why we had potentiometer as a precaution. No? We had potentiometer as a precaution, right? Voltmeter के error करती है ना, voltmeter के error නැති වෙන්න නේ potentiometer के use करे, right? So ideal scenario එකක් නම් වෙන්න ඕනේ. In ideal case, right? Internal resistance of voltmeter is infinity. When internal resistance is infinity, there's no current flows through the voltmeter. There's no current flows through the voltmeter. Right, now back to the question. Now resistors are connected here as this. Then voltmeter should be here like this. No? Voltmeter should be here like this. Now resistors are connected like this. Right? And voltmeter appears to be connected. The voltmeter now appears to have been connected across RXY. Across RXY. Right? It appears to be connected across RXY. Resistors appears to be connected across RXY. If this is RXY, now voltmeter appears to be connected across RXY. Something like this. Something like this. Now RXY represents total resistance. RXY represents total resistance. When RXY represents total resistance, right? Then total current flows through the resistor only. Total current flows through the resistor only. Right? voltmeter එක resistor එකත් ඒකට factor කරලා ඉවරයි. We have already factored the resistance of voltmeter into RXY. Right? That is inside the RXY now. Right? Then no current flows through this voltmeter now because current flows through the resistor. Resistor එක මම වෙනම අරන් තියෙන. Resistor is already separated now. Then no current flows through the voltmeter. Therefore, this is equivalent to the ideal case. Then we can say it is yes. Yes. Justify your answer. Since no current flows through voltmeter, it's working as an ideal voltmeter. It's working as an ideal voltmeter. Right? There's a small thing in there. The small thinking. Right? ඒ thinking එක හිතන්න වෙනවා. ඒක පොඩි thinking එකක් තියෙනවා. Have to think. Right? Next. See, if V is the reading of the voltmeter and I is the current through the ammeter, write down an expression for I in terms of V, R0 and R. Right? Now, if a current I flows through ammeter, that same current flows through RXY, no? Because now equivalent of V and R is RXY now. Now the same current flows through RXY. Then apply delta V equals IR. Right? Then delta V is V of the voltmeter, V, I is I, and R is RXY. RXY is already simplified. Plug that here. Then V equals I times RXY was R0 over capital R plus R0. Write down an expression. This is enough. Expression na kidhar aaye hone. That is the expression. Right? V equals I R0 to R plus R0. Right? D. Rearrange the expression given in C to plot a graph of 1 over V on y-axis and 1 over R on x. Right? Then make 1 over V. Sorry, I over V. I over V and 1 over R. Then make I over V කියන එක subject කරගත්තා නම් හරිනේ. Right? Subject I over V from this equation. Right? From this equation, subject I over V. Then when I over V is subjected, මේක දැන් ඇවිල්ලා තියෙන equation එක equals, this is the equation we have got. V equals I times R0 over R plus R0. Subject I over V. Right? Cross multiply V to the other side. Then it becomes R plus R0 over R0. Right? Then y-axis is okay. X-axis is 1 over R. To create 1 over R, we can divide both terms on the numerator using R0 separately. Then this is I over V equals, this can be divided separately, R0 plus simple R0 R0. Right? These terms are going to cancel. Capital R to capital R, R0 to R. Right? Then we can keep the final answer as I over V equals, right, 1 over capital R plus 1 over R0. Right? Then this is our y-axis, this is our x-axis, and this should be the intercept. Y equals x plus c, because m is 1, that is mx plus c. M is 1 here. Right? M is 1. Right? Next. E. Draw the shape of the graph expected in D above on the set of axes given below. Right? Then that is x plus c. X plus c means that is mx plus c. M is 1 now. Right? mx plus c tamai. M is 1. Then mx plus c කියලා කියන්නේ something like this. mx plus c. Draw the shape of the graph. Right? Shape is drawn. Next. Write down an expression relating R0 and the relevant information extracted from the graph. Ah, you can see 1 over r naught is with the intercept, no? Right? Which means intercept of graph equals, see, intercept C of graph is 1 over simple r naught. Write down an expression relating r naught, right? Relating r naught, then the expression is C equals 1 over r naught. C equals 1 over r naught. Expression relating r naught. C equals 1 over r naught. C equals 1 over r naught. G. If you are asked to perform an experiment in the laboratory, and plot the graph mentioned in E above, name the item which you would use for R. Right. Then here R is a variable. Right? As variable resistors, we only have two options in lab. Right? In the laboratory, we only have two options in the laboratory. One is rheostat. Rheostat is used when you need to get a variable resistor, right? Or if you need to change the variable resistor to any value as you wish. Right? All continuous values. Any value can continuous values. And if you need to change R in finite values, finite or distinct values, finite never distinct, right? Monahari values, if you need to do it for some given values, right? Distinct values, we are using resistor box. Rheostat and resistor box, right? Now in this case, we need some distinct values of R, right? R world value graph. So that is a distinct value of R, then resistor box is used. Resistor box, right? H. Suppose the resistance R naught is now removed from the circuit shown in figure 1. Assume that R naught equals 1000 ohms. Capital R naught is removed. Capital R naught capital R naught. This one is removed. Right? That one is removed. And internal resistance of the voltmeter is given as 1000. Internal resistance of the voltmeter is given as 1000. Consider the magnitudes of the following voltages. The reading of the voltmeter, say V1, right? Reading of the voltmeter. Second one, the voltage generated across XY when the voltmeter is removed from the circuit. When the voltmeter is removed, that's a good point. Always when the voltmeter is connected, it absorbs the voltage, right? Always when a voltmeter is connected, it absorbs the voltage, right? Okay, potentiometer issue. The issue we had to choose potentiometer, right? Always voltmeter is connected. When voltmeter is connected, it absorbs the voltage, right? It absorbs a small voltage, small current. Current means IR drop, then a voltage is absorbed. Then if the voltmeter is removed, then the actual voltage will be there across X and Y, right? Actual voltage with the actual potential difference will be there across X and Y. Third scenario, if a digital multimeter having an internal resistance 10 mega ohms is now connected across XY. The reading of multimeter, say V3. Right. Write down E0, V1, V2, and V3 in ascending order according to their magnitudes in ascending order. Right. Minimum voltmeter reading should be the reading now, right? It should be the reading now because it has a resistance 1000 ohms. Now, right? It has a resistance of 1000 ohms, right? Lower the resistance, higher the absorption of voltage because resistors are in a parallel combination. Resistors in a parallel combination nekkane. Toda api kalanut dan kada karane. Okay, ideal case sekunut them resistance ke infinity vena. When there is ideal, no current flows. Ideal case sekunut tama infinity venne. Then more towards the zero side, which means that is deviating from that ideal scenario. Right? More towards the higher side, towards infinity, higher side, right? Mega ohms, omega, giga වගේ values වලට යනවා නම් then that is more towards that higher side, then error is less, right? එතකොට මේකේ වැඩිම error එකක් තියෙන්නේ. වැඩිම error එකක් තියෙන්නේ when the voltmeter is connected now, right? Then highest error means that's a minimum reading because higher voltage is absorbed. When higher voltage is absorbed, the reading is minimum, then V1 should be minimum. V1 should be minimum, right? Then if the voltmeter is completely removed, the actual value between X and Y will be measured. Now, other than that, before that, we have a 10 mega ohm scenario. No? 10 mega ohms, a higher resistance. Higher resistance means lesser voltage absorption. Lesser voltage absorption, which means a higher reading is read. Then V3 comes next. V3 comes next, right? And then I can easily decide that battery is the highest voltage here because a part of the battery, a small part from the battery is acting across the resistor. No, battery එකේම total එක ඇවිල්ලා නැහැනේ, only a part of the battery. No, battery is the highest. Since battery is the highest, then V2 should be in between. Then V2 and battery is the highest, right? This is the order, ascending order, right? Again, a small thinking part after these first first 7-8 questions we had, right? Okay, take it down and you can ask if anything before moving on to the next. You can ask if anything before moving on to the next question.